All right, so today we're gonna try to get vulture to vulture collision working, because right now our vultures hit each other, they just don't do anything. So I'm a little curious if our vulture bouncing problem is just that they're jumping twice back to back, or if they're bouncing for some reason. Because it doesn't happen all the time. It just happens every once in a while. So I think the programming for their jumping might make it so that they can jump again right as soon as they land, but I'm not exactly sure. Maybe we'll test that, debug that a bit. In our play state, that's where we're gonna do our loop to check. We're looking for vulture collision with another vulture. So for every vulture, we need to check collision for every other vulture. So, for cave vulture and pairs of vultures, we need to say if a vulture, how do we do this? No, yeah. Let's try it. So this is going to do something a vulture's amount of time, which right now is 3 vultures. So for every vulture, so it's not that we want to run the line of code 3 times, it's that we want to run every vulture for every vulture. So we've got to do a nested. Is this how we would do that? I think this needs to be a different name. So like we need to, for every single vulture, we need to check that vulture against every other vulture. So the thing is, how do we say we want to check it against every vulture except itself? I know how to do that. We would say, if our vulture's index does not equal, which does not equal, crap. I know we've done does not equal, I'm just forgetting what it is in Lua. I'm forgetting it. Non-equality in Lua is what? Tilde equals, that's what it is. It's just so random. How do I do this? So for every vulture, we need to check that vulture against every vulture that's not itself. So I do think this needs a different, we need to give a different value name than vulture again. So like for every vulture, check every vulture. Yeah, we want to see if vulture index is not equal to the index. So we can say if it's not, if the vulture's index field does not equal our current index. So for vulture 1, our index is 1. So this line of code will not run the check collides with C. So vulture, this is why we need it different, because this vulture needs to get this vulture's index. I don't know what to do about that. Or like, you know, we need to say collides with vultures. So like that's, yeah, we do need two different variable names here. But we need a, you know what, we have a true AABB collision, which is great, because we don't need the top and bottom collision, we just need the true. So, but the thing is, our collision, we need a, we need the function to be on in our vulture class. So unless we have a true vulture collision, which we don't, let's add the true collision here. So this new function is going to be used on a vulture. It's called collides, and it takes in a vulture. Parameter. Okay, so now we have a function called collides that we can use on our vultures. I guess there would be a way to no, because we need to run it against itself, so I don't know how we would be able to use it for both an ostrich and a vulture, the true collides, that is. But this is fine, this will work. Okay. Okay, so now in our play state, we can go vulture. So that means the first of 3 vultures, checking for collision in all the vultures. We run it with each of our vultures that aren't at our current index. So since we manually link our index field in our vulture object to the proper index in the table, we do that right here. We explicitly say it. Actually, we do it in the instantiation right here. So this argument is the field member, whatever you want to call it, right here. So that gets set as our index. So that should work. So this is looping through every vulture, and then this is looping through every vulture that's not that vulture checking for the collisions. So every vulture will be matched. Yeah, it'll run this. This needs to be an S, and this needs to be collides, I'm pretty sure because, yep, capital C and collides. Okay. So then we're going to say if our vultures collides with, actually this is if our vulture collides with the vultures. Yep, other vultures. Maybe this is like others. Vultures.index does not equal index, and this index is just the index of our loop. Yeah, maybe we say I think others kind of makes sense. Because, you know, if vulture collides with the others, and we're only running this if this will be every other, we say only run this if your others index does not equal the current index. This isn't exactly right. Hold on. No, that should work. Maybe. So yeah, we're checking the index field of every other vulture, but that includes itself at the moment. But the thing is, this not equals index is supposed to negate that checking against itself, because we're saying if the others field is the same as this index, meaning vulture 1, or vulture 2 and vulture 2 index, you know, we're only running that if it's not equal. This should work. And we're gonna very simply reverse our dx and then reset our other, because I'm deciding to reset other and not our vulture, just because. If vulture collides with others, then vulture dot dx gets itself times a -1 with just that. We're going to swap our others dx as well. And then we're going to set our others x to be equal to our vultures x plus our vultures width. I'm hoping that's all we needed to do to get our vulture to vulture collision working. So we're cycling through every vulture, and for every vulture we're cycling every vulture against every other vulture. And if the index is not equal to the current index of the loop, meaning it won't run this collides on the same index, only on other indexed vultures. So that's the idea, but I'll be impressed if it just works. Yeah, okay. What did you not like? Unexpected symbol. That's because an equal sign is not supposed to be there. Okay, it didn't work. Did not work at all. The vulture collides function. So what if we take this line out and we just run it? Because the thing is, okay, that was not what I was expecting. I was expecting everything to break. Well, I didn't save it, so let me save it and try it again. So, yeah. So that function is working. Oh, God. The function's working. But the logic is not. So... yeah, something wrong with our index logic. Okay, so for key value, so this is like the index, and this is the value in the table. So we're saying, you know, cycle through all the vultures, and for every vulture, you're gonna cycle through every vulture again. But if the value of the index is not equal to index, okay, yeah. Let me see if our function is working first off. So we're gonna hard code vulture 1 and 3 collision into our play state debugging, and we're gonna say graphics.print we're gonna print vcollide, and it's gonna be our function, but we're gonna run it on vulture, what it was 2 and 3, right? We're gonna say vulture 2, we're running our collides function on, well, we know it was working, it was doing, when we turned off that loop, it was going all crazy, so the collision was working, it was just detecting collision with itself. So something in the index thing is messed up, I'm pretty sure. Vulture 2. So vulture 2 collides, no, vulture 2 with vulture 3. 2, vulture 3, vulture 3. Okay. But we need at what, 5 and 5, whatever. Let's see. Oh, it's 1 and 3. So if it turns true, yeah, it did. Okay, so the collision's working, so it's just the index that's messed up. It's just this line that's getting screwy. So what if we do... I don't know why this wouldn't work. Shoot, man. Yeah, the index just isn't working. If we put this to be an equals, an equality operator, it should give us the messed up one again, right? Yeah, so it is, that line is, it's just this line that's busted. So what's another way of saying not to run collision detection on itself? I thought the index was the perfect way, because the indexes should be the same exact index in the table looping. So we're saying, or index others in pairs vultures. Like I want to see hard coded just one of them work, you know. Which is something like this. We'll say if vulture 1 collides vulture 3, then swap vulture 1. This is vulture 3. Okay. See, it's like we don't want to have to type all this stupid code for every single vulture combination, you know. We just want to do the nested table loop. Okay, not exactly right, but they should have swapped dx at the very least. Yeah. See, that's what happens when you don't reset the x position. So that's working. It's really just the logic. I don't know what's wrong with this logic here, using our index here. Maybe if we check the index first, if index equals others.index, then we want to say something like, see, the not equals should work, but I'm just trying to get it to work. Like if index is equal to others index, I want to do nothing, but otherwise there's a collision, do all that stuff. Still not working. Something. Yeah. I don't know. I don't know why this is not working. You can do nested table loops, right? Oh yeah, maybe we do a for loop instead of a because we need access to the objects. So I will give us access to the index if we do a for loop, which could work. So maybe we do what is the syntax? I already forgot the syntax. For initialization, comma, limit do. So if we want I to be an index, we would say for I gets 1 for limit however many vultures, which are currently 3, do something. And the something we want to do first is see if I is equal to the vultures index. Maybe that was the problem right there. We were checking others index instead of the vultures index. Yeah, hold on, let me try. Oopsie. Yeah, I think this needs to be vultures index. Just vulture index. Let me see if that fixes our problem. If not, we can try the for loop. Fuck. I was thinking that would work. Okay. So yeah, that's not what I want. Oopsie. Here we go. Let's try this for loop. Yeah. I gets 1 in the 3 vultures we have. The first thing we're going to do is see if our vultures.index is equal to our I. We should say if I is equal to vulture index, then do nothing else. See if that vulture collides. Let's see. See, we can't do that. We need to loop through the table, not just a loop. Unless we're saying, God. Because yeah, we need to check every single ostrich against every single other ostrich, so it needs to be that nested loop. Let's try this again. I'm going to use a different index than up here, even though I feel like I've done it before and it worked fine. I'm just going to switch it up. So I'm going to say for I vulture and pairs vultures. So it takes in a table of our vultures. It's going to do this. This is just a for loop for the amount of table indices we have and access to the value. So then we can say for index others in pairs vultures do something, and we're gonna say if our vulture index is not equal to the index currently, then we're gonna set, oh no, then we gotta check the collision, which is if vulture collides with others. And if so, I'm just gonna say vulture X gets 0. Just, you know, I just want to see if that code block executes. Yeah, I know. I don't know how that didn't save, but okay. All right, then expected. Yeah, you're right. You're right. Okay, that worked. That worked. So we're instead gonna swap our dx. Okay. We're gonna swap our dy. No, no. We're gonna swap our others dx. Others dx gets others dx times -1. And lastly, we're gonna set our others x to be equal to vulture's x plus vulture width. And now we'll see if they bounce off one another. All right. They're never going to hit each other unless I stop them. Come on. Okay. I couldn't tell you what the fuck's happening. Bro. How about... Oh, see, it depends? Okay. It depends on which side. It depends on which side. Because right here, we're assigning our others ostrich's x to be the right side of our vulture, but if it's a left collision, we need to set it on the left side. So we need to also test which direction they're facing. So if vulture, we can just compare the x values. So we say if vulture's x is smaller than others' x, then that means our x reset. We would move our others to be, this would mean our vulture's on the left side of our other vulture. And if that's the case, we're moving our other vulture to be the right side. And then otherwise, we need to move the x to be the left side for a vulture, which would be a vulture's x shifted by our others dot width. So now maybe. Okay. Not right, but okay. It just pushes them. Fuck. It just pushes them. See, why wouldn't our ostrich or others, our DX isn't getting swapped for some reason, but we're swapping it. It's almost like we need to check. It's like we'll reset the way they're facing first, then apply the DX. That doesn't work either. Fuck. What's weird is if I bet if we print up the DX for our ostrich that's moving to the right, our DX would, when it was getting pushed but facing left and walking, it was getting pushed. I bet our DX would still be negative even though we're moving to the right because we're resetting our X position to be the right side of our vulture. So actually, yeah, what's happening here? If they collide, if our vulture's on the left, set our other vulture to be the right side of it, and then swap its DX. Why doesn't that work? I don't get why it would push it, because the DX should be swapped at that point. Okay, I don't know. This is wrong. This needs to be here. Come on, dude. Bro. I don't know what's happening. So, like, what's the first thing that's happening? Ostrich 1 gets with Ostrich 3, and 3's DX doesn't change. Are we sure 3's DX doesn't change? Let's print up Vulture 3's DX and see if it changes upon that collision. We'll say this is Vulture 3 DX, okay? And this is Vulture 3 DX. Now we'll see if we're actually swapping our DX or not. Yeah, we're not. I don't know what the fuck's happening. What if we just shift it by a couple more pixels? Just to see if that stops the pushing and assigns our DX. It did. I'm not exactly sure why, but that fixed it. Let's just give us a 1 pixel buffer instead, see if that works. Okay. Chit. Okay. Nice. They jump at the same time, don't they? Do they always jump at the same time? It looks like no, well. Okay. So what is it about setting, if we set the other ostrich to be the right side of our vulture? with a swapped DX. See, that shouldn't trigger another collision. We shouldn't need this +1 in there. Okay. But if we take it out, they get pushed. Because multiple collision detected, I guess. I don't know why we need that. I don't think we should, but we do for some reason. Let me take off the numbers and see if it looks believable, or like, you know, if it looks like they actually collide. Oh, come on, what? Okay. It's like a Newton's cradle situation going on. Okay. Well, we figured it out. One thing I mean, you know, I'm not happy with the fact that we have to move, you know, have that pixel buffer in there, but I guess it's okay. Well, we got that working at least. I want to see if I can see why the jumping is so weird. You know, what if we set math.random to our index as a seed? So we can say math.seed. What is it? Set, no. Random seed. Let me see. Love 2D set random seed. Love.math.set random seed. Okay. Love.math.set seed. I already forgot. Set random seed. This is, I'm hoping, gets them to jump on different frames, so they don't just keep jumping on the same frame. It looks like it worked. Well, maybe not. No? Okay, yeah, they kind of jump. Yeah. They jump kind of randomly. Sometimes at the same time, but sometimes not. So I bet if we were to do a 1, 2, 3, it would be even more random. But actually, we want them to. I mean, we got to rehaul this jumping logic anyway, a lot. That'll probably be next. Because they actually, instead of how they're doing it now, they just jump once and then keep their aerial mobility. None of the oh shit, they're all no way. Really? Okay. Okay, I mean, yeah, they don't always jump together, but I would like it even more random than that. Not, I feel like the random seed would make him jump totally different than this. I don't get why sometimes they're all synced. I don't want them all synced. Anyways, that's okay, because we need to rehaul it anyway, because if you look at the original, their flap has to like look at the logic of the first one, right? For how often they fly. They kind of flap like crazy and their jumps don't bring them so high, but they keep in the air a lot of the time. See how they're kind of crazily flapping a lot of the time? We need that. Totally different. And they move a little bit slower in the original, so we can slow them down a bit. But we need to rehaul that next episode. We did get the vulture collision detection working, which is good. We still need to fix, actually, I don't know if I saw this now that we changed our timing a little bit. I don't think I've seen a bounce for a little while. But yeah, we need to slow our vultures down a bit. Whatever our speed, what's our DX? How about a 0.6? I think they're actually smaller than that, but... Oh, and you know what? When we instantiate our third one, we give DX, don't we? We switch, yeah, right here. This needs to be a 0.5. Just, I mean, that's not hard-coded. I mean, that's not final. We're just... Oh, fuck. Look at that shit. Oh no. Why is that all of a sudden back? You saw it drawing those pixels, right? Why does the speed have anything to do? Look, if we go to 0.1, we want to go to 0.1. Both of them, or all of them. Yeah, you see the frame there? Like the pixels of the next frame creeping in. See that? Green. We need to fix that. I'm curious if we switch our viewport to 1. If that'll make the problem better or worse. Worse. Because now we're cutting off the butt. He cut off the butt. What if we do That wouldn't work. Yeah, okay. Those only seem to show up when we slowed down. Fuck. I don't know how to troubleshoot that. You know what? Maybe... Oh, you know what? Wait. Let's... Where do we... Where's our frame 3? Something could be messing up in this self offset here. Oh my god, because yeah, we're just the frame. Okay, that shouldn't be. Fucking shut up. Part of me is curious if I add an offset by 1 here on these, if that makes the problem less. Nope. Okay. What if we do it the other way? Bro, that's kind of annoying, yeah. Fuck. And then we were only getting that problem when we slowed down. But what's weird is we don't have that problem when we slow down, just when the vultures are slowing down. So maybe... Fuck, I don't know what the move is. Let me open our vulture sprite. There is a pixel in between those, right? See, I thought that's why we had to add a pixel. But it looks like there is a pixel difference between each of them. But it's just not working. I'm gonna see if we're actually seeing our butt or not first. Are we actually seeing our vulture's butt? No, we're not. We're not seeing our vulture's butt. So what if, when we set our viewport, hold on, I'm kind of curious. Fuck. I think that's just undoing the freaking problem we fixed. Hold on. I just want to see if that changes anything. No. Actually, yeah, it makes it worse. But we're drawing 1 pixel too far. on everything. We need to have the X offset one less frame, so... Hold on. Okay, now we're seeing her butt. And now we're not getting the problem. Okay. Oh, shit. Do the vultures not have the buffer zone for the collidables? Because I just saw that they didn't. Okay. Well, we fixed that. No, we didn't. What? Bro. Not what I wanted. Yeah, we don't want that. We just want the -1, I guess. That's so looks like crap. X offset is current frame plus its width times its self.frame -1. Shifted by 1 pixel. See, so why is that busted? Why do we have to shift it by 1? Because if frame's on frame 1, we get times 0. So frame. Oh, this might still be messing shit up. We need to make sure we've got the buffer. Wow, yeah, that's so fucking jacked. When they walk off the edge like that. They really don't have... Wow. Yeah. So we're... You know what? Yeah, see, we're actually using... Oh, no, we do have the buffer here. Okay, so let me just speed them up a bit again to their normal speed and then see if we get any of those weird things. They look a little wobbly, don't they? Maybe not. I thought they looked a little wobbly. Okay. Well. Okay, well, we implemented our vulture to vulture collision detection. It just took a little longer than I was thinking. But we got them at a decent speed. They're interacting with each other. So next episode, we're going to be changing their jump logic to be more game accurate. And then after that, we'll work on turning them into eggs. Sound good? So we'll do a get stat just to be cute, or a get log, is it? Nope. What's the, oops. There's a get command where you can see the changes. I want to say it was, yeah, it is stat. Oh, I guess you got to commit to see it. Okay, we're gonna get commit with adding everything to our staging area. We're gonna say added vulture to vulture collision logic. We're gonna get push that up to our origin repository, and we're gonna run a get stat and see we added 16 lines in our vulture class, 19 lines in our play state class. It's just a cool way to kind of visualize the work, you know. It's not super accurate because of the tabs and everything, you know, like I doubt we did 865 differences there, but that's what it says. Anyways, tomorrow we're going to be doing, I haven't seen this problem yet. I'm going to tentatively put the X there, but we need to fix or make vulture jumping more accurate. Okay? And then, yeah, that's what we'll be doing tomorrow. Thanks for watching today, and I'll see you later.